Today we'll be creating tables for proportional relationships. Okay, so proportional relationships are similar to equivalent ratios, where each of the ratios all simplify to the same exact thing. Well, proportional relationships, that's going to be true throughout the table. Okay, so Misty is buying shirts for her doll that cost $3 for $5. So 3 shirts cost $5. And I can go ahead and fill that into my table here. 3 shirts for $5. So the number 3 in this situation represents the number of shirts. The number 5 in this situation represents the total cost. And you'll see in these tables, often we refer to these as X and Y. So in my X row, all of these numbers are talking about the number of shirts. And all of the numbers in my Y row are going to be talking about total cost. Okay. And when we buy 0 shirts, it's going to cost us $0. Okay. Because it doesn't say there's any fee before we buy anything from that store. Okay. So 3 shirts cost $5. Well, if I buy 6 shirts, I'm taking 3 and I'm multiplying that by 2. Well, if I multiply it by 2 on the top, I have to multiply it by 2 on the bottom, just like if you were doing a fraction. Okay, so finding an equivalent fraction. So 3/5 equals 6/10, right? Whatever you do to the top, you have to do the bottom. And we can do the same thing here. 9 would be 15. Okay, 5 times 3 is 15. 3 times 3 is 9. Okay, so 9/15. Okay, now we take a look at this, and in a proportional relationship, it's going to have this point 0, 0. It might not always be shown on the table, but it would be true about the situation. Okay, so if we bought 0 shirts, it would cost us $0. Okay. Now, my change, how much it goes up each time, notice, is 5. And that stays the same all the way through. And my change on the top is it increases by 3 each time, and that stays true. And my ratio of that change in the y value to the change in the x value is 5 to 3. Okay, now if we look from 0 to 9, that goes up 9, and 0 to 15 goes up 15. But if I still write that ratio as the change in y is 15, the change in x was 9, notice 15 over 9 simplifies to 5 over 3. Okay, so those are equivalent fractions. Okay, and we're talking about the change. We do the change in the y over the change in the x. Okay, that's how it's typically represented. Okay, so let's take a look at the next example. Each avocado at the store costs 50 cents. Okay, one avocado, so each refers to one avocado, costs 50 cents. So we're going to put that here on our table. One avocado is 50 cents. Well, if we multiply that by 2, okay, on the top, I'm going to multiply that by 2 on the bottom. That's going to give me 1. Okay, and then I can also, in a table of a proportional relationship, I can jump across the table and do the same thing. If I wanted to take 2 and multiply it by 2, I would get 4. Well, then I would take the 1. See here, 2 and 1 go together. So if I'm multiplying the 2 by 2, I would multiply the 1 by 2 because those go together because 2 avocados cost $1. Okay, that's why they go together. All right, so 4 avocados would cost $2 because we would multiply 1 times 2 and that gives us 2. Okay, now if we use this idea that we talked about, the change of our y and the change of our x, in this problem, my change in the x goes up by 1 each time, right? Plus 1, plus 1. Well, for every 1 avocado, it increases by 50 cents. So as we increase, we go plus 50 cents. Well, I could add 50 cents again. So 1 plus 50 cents. Okay, because we added one more avocado, which means we're going to add 50 more cents. All right, so you can use either method here to fill out these tables. Okay, but this represents 4 avocados cost $2. Okay, and my change would be 0.5 over 1, okay, which is your change in y over change in x, okay? And this could also be written as a fraction, 1/2, okay? Half a dollar over 2. All right, but because we're talking dollars, typically we use decimals, but you can see these as fractions, okay? There's a couple more down here for you to try if you'd like to fill those out, get some practice.